Okay, next we're going to take an overview we're going to do a review of MPF from the, let's say pretty much, we should know this from the CCNA class, but just a review of MPF, and then we're going to go to a couple of MPF configuration options. So MPF stands for Modular Policy Framework, which means it is going to be a framework which provides granularity and flexibility for advanced ASA for all policies. Pretty much, to keep it simple, it's a framework that whatever is kind of a special configuration on the ASA, some advanced inspections of the traffic, it is going to be done via MPF. That's why it's called, it's a framework which allows the for all policies of the ASA to be modular. There you go, the name, Modular Policy Framework. Now, MPF can be used to enable stateful inspection of additional protocols like ICMP and ESP, which is not inspected by default. So what that means is that by looking back at our diagram, you're going to see even if traffic is allowed to flow high to low, 100 to 0, if it's of type ICMP and if I send the echo request, because by default ICMP is not statefully inspected, I send the echo request out, but then the echo reply, it is going to be dropped because by default ICMP is not inspected, echo reply. So if I don't enable ICMP inspection, the reply is going to be dropped, the return traffic. Same goes for ESP. If, for example, PCB, let's say, has built a IPsec tunnel with router tree through the ASA. So PCB has an IPsec tunnel built with router tree, and let's suppose that they have negotiated to use ESP as the encapsulation, because ESP is not safely inspected by default, because this interface has a level of 100 and this interface a level of 0. It means that PCB is going to be able to send ESP traffic out to router tree, data plane traffic through the IPsec tunnel. But as router tree is going to reply with ESP traffic, is going to likewise be dropped by the ASA, because ASA does not by default inspect ESP. So with MPF we can additionally enable inspection of ICMP and ESP traffic, so that if that kind of traffic is allowed to flow through the ASA, we want the ASA to be able to also allow the return traffic of ESP and ICMP. But of course MPF is mainly used, as we said, for other purposes, additional purposes, to provide advanced capabilities of the for all policy on the ASA. Like we can do advanced TCP inspections. We're going to do also dynamic protocol inspection. We'll see what that means. We can do DPI, deep packet inspection, or application inspection. It can also be used for quality of service, and it can also be used to redirect traffic passing through the ASA to the ASA's software or hardware module, which can be the IPS module, the ASA CX module, or the Firepower module. So we can make use of MPF to redirect traffic through that module for advanced inspection. Also, as we saw, MPF was also used for NetFlow, for example, on the ASA. So as I said, in general, whatever is going to be is a kind of an advanced inspection on the ASA, you're gonna see that being done via MPF. Now the building blocks configuration wise, MPF is very similar to iOS MQC syntax, is very similar to the iOS zone-based policy for all, for example. Likewise, it makes use of class maps, policy maps, and service policy. Those are the three objects we're gonna be using to configure pretty much all of our MPF policies. Now, just like in the case of iOS with the zone-based policy firewall, the class map can be of type layer 3.4 or layer 7. So if it's going to be a layer 3.4 class map, that's going to be used to match on traffic for which a firewall policy is required. So as in the case of zone-based policy firewall, the layer 3.4 class maps, the layer 3 or 4 class map, which means it's going to be able to match on the layer 3.4 headers of packets. It is used to classify packets. It is used to match on which traffic. So it is used to identify for which traffic do I want to build a firewall policy via MPF. While the layer 7 policy map class map is used to match on traffic for which application inspection is required, just like in the case of zone-based policy firewall. So it means that layer 7 policy map is going to match on a layer 7 header of traffic which I want to inspect, for which I want to do application inspection. Then the policy map likewise can be of layer 3, 4 or layer 7. The layer 3, 4 policy map is used to define a layer 3 or 4 firewall policy like QoS, like NetFlow, like advanced TCP inspections, like dynamic protocol inspection, everything which is not application inspection. Everything else, so whatever MPF supports which is not application inspection, I'm going to enforce those policies against the traffic by using a layer 3, 4 policy map. While the layer 7 policy map is going to be used to define layer 7 firewall policy, which means it's going to be used for application inspection. And then the service policy is used to activate the configured layer 3, 4 firewall policy. So as you're going to see, just like in the case of zone-based policy firewall, the application inspection configuration is not applied like a firewall rule. It's an additional option to a firewall rule. So for that reason, as it was in the case of iOS, you cannot apply a layer 7 policy map at the firewall level just somehow. You can only apply a layer 3 or 4 firewall policy to enforce. You can only apply a layer 3 or 4 policy map to enforce the firewall policy. And it can be applied globally or at the interface level. So the policy map of type layer 3, 4 can be applied globally or at the interface level. Now, there are very few exceptions. If the policy map of type layer 3, 4 is applied globally, the firewall policy, with the configured firewall policy within the policy map, applies in the inbound direction for all interfaces. So if it's applied globally, it globally affects all traffic flowing to the ASA, but it applies only in the inbound direction. And it makes sense because it applies to all interfaces. If the policy map of type layer 3, 4 it's applied at the interface level, then the configured firewall policy in that policy map applies in both directions and for that interface only. And this makes sense because if it's applied at the interface level only, maybe some traffic is going to be just outbound, some traffic is going to be just inbound. So again, what this means is that if you apply the firewall policy, the MPF policy globally, with few exceptions, it means that it's gonna affect all traffic coming inbound on all interfaces. It affects all interfaces, and it means that that firewall policy which was applied is going to be enforced inbound on all interfaces as traffic is being received. If the MPF policy, the layer 3, 4 policy map, is applied per interface, like I apply it inbound in here, it means that that MPF policy is going to affect only traffic coming in that interface or going out that interface. So it applies bidirectionally in both directions in this case, because maybe you only have traffic inbound or maybe you only have traffic outbound. It makes sense that for the global policy, if the policy is applied globally, it's not applied outbound as well. Because if the global configured policy would have been applied in both directions, both in and out, it would mean that a traffic flowing through the ASA, it means that that traffic could be inspected twice by the MPF, which was wrong clearly, because it comes inbound on this interface, so it's going to be inspected once, and then it goes outbound on this interface, so it could be inspected second. So because it doesn't make sense, and to avoid this confusion, that's why a policy configured globally on the ASA, it globally affects all inbound traffic only on all interfaces of the ASA. For example, if you look in the MPF, let's say in here, let's go on Google and say Cisco MPF, not using. Let's see. I'm looking to. I want to quickly go in the configuration guide. Not this document, or does this document also show what I'm interesting? For example, yes, there we go. So as you can see in here, if the MPF policy is applied globally, global direction, for pretty much all options, it is going to be applied in the ingress direction. So if I do any kind of advanced inspections, like TCP, UDP, connection limits, and TCP sequence number randomization, is going to be applied ingress. For CX inspection is going to be applied ingress. For application inspection is going to be applied ingress. For IPS inspection is going to be applied ingress. Only for QoS, so QoS makes a difference. Only for QoS it applies in the egress direction of that interface. Because ASA supports policing and traffic shaping. Only of course, for policing it can be both ingress and egress, depending on how you configure it. Because ASA, like also an iOS router, supports policing both ingress and egress. But then for priority queuing and traffic shaping, because those are anyways outbound functionalities, you can only shape traffic outbound on Cisco. On other vendors you can also shape it inbound. So on Cisco you can only shape traffic outbound, and clearly priority queuing means only outbound or egress. So it makes sense that for those examples, even if the policy is applied globally, it's going to affect traffic in the egress direction. So now the reason I'm saying this is, like anything which you saw me doing so far, is because I want you to memorize as least as possible. So everything in here, it makes sense. So if you apply the policy globally, pretty much is gonna all MPF policies configured, if they are applied globally, are gonna affect traffic ingress on all interfaces, except a couple of exceptions like policing, because you can do it both in and out, or shaping and queuing and strict priority queuing, which is only outbound or egress, and it makes sense. While if you choose to apply the policy, the MPF policy at the interface level, single interface direction, and as you can see, for the same options, then that policy applies both ingress and egress for traffic both received inbound on that interface and also routed outbound on that interface. And it makes sense, as I said before. The exception is again for QoS, which the same rules are going to apply for QoS. So policing, depending if you have configured ingress or egress policing, is going to clearly be applied ingress or egress, not both ways. While for priority queuing and traffic shaping, this is only a outbound feature. So likewise is going to be applied on the egress direction only. Now MPF, there are some default settings. ASA has the default class map configured, named inspection default, which it matches on all traffic. ASA also has a default policy map configured named global policy, which has the default class map attached, which performs layer 3 and application inspection by default. So the default policy map that does both application inspection and layer 3 stateful inspection. And the default policy map is globally applied by default, which means it affects all traffic traversing the ASA. As we saw before, either in the ingress direction the policy is applied, or in the egress direction for QoS. If you go on the ASA 3, and if you say show run class map, you see the default class map name inspection default, which matches on default inspection traffic, which actually that pretty much means not exactly all traffic, but all traffic which the ASA supports for inspection. If we say match default inspection traffic, it means it's gonna match on all of those protocols contained in this square, which is the protocols that ASA supports for any kind of advanced inspections. So it's not exactly all traffic, it's all traffic supported by the ASA for any kind of advanced inspections. Then that class map is called within the policy map. Show run policy map. We have the global policy map, the default policy map called global policy, which has attached the default class map called inspection default, and performs some kind of inspections for some types of traffic. And then that policy map is by default globally applied. So we have service policy, the name of the policy map, which is by default globally applied. Okay. Now, as I said, so if you look in here, for example, for DNS, we're gonna look in the applications, in the application inspection part, that it performs by default application inspection. For other protocols, it only performs protocol inspection. We're gonna see exactly why when we go to the dynamic protocol section. But for the moment, let's just know that the ASA has a default class map matches on all supported traffic for inspection. Then has a default policy map where it does by default both protocol inspection and application inspection. And by default, that policy map is globally applied, which means it affects all traffic passing to the ASA, and the MPF policy is applied in general in the ingress direction, or for QoS in the egress direction. So configuration wise, we're going to follow up on the blocks, which let's say we would want to inspect ICMP, which is not inspected by default. If we make use of the ASA defaults, like the default class map, default policy map, and default policy map being applied globally, we just need to enable ICMP inspection in the default policy map, and that's it. Which means it's going to affect all ICMP traffic traversing the ASA because the policy map is globally applied. If we don't want to make use of the ASA defaults, which means we may want that if we want to inspect ICMP traffic only for example, for specific between specific sources and destinations, then not using the ASA defaults, we can match on the ICMP traffic using an access list. Then we configure the layer 3-4 class maps and bind the ACL in the class map. We configure the layer 3-4 policy map and bind the class map within the policy map. And then we apply that policy map globally or at the interface level. Of course, you cannot have more than one global policy applied or more than one policy applied per interface. It doesn't make sense. So if you can have only one policy applied globally and only one policy applied per interface. And of course, in case you have both of them, then the interface configuration is going to be more specific. The interface one is more specific, is going to override the settings of the global one. Verification wise, so those steps are just like in the case of iOS. Zone-based policy firewall, class map, policy map applied, but just different command structure because it's a different platform. Verification wise, we verify the configured class maps, show running config class map. We verify the configured policy maps, show running config policy map. We verify the applied policy maps, show running config service policy. Or it's a better way to verify the applied policy map and also look at the statistics of the traffic's show service policy.